Algebra 1, Arkansas Framework, NLF 4, AI 3. Solve quadratic equations using appropriate methods with and without technology. This includes factoring and using the quadratic formula. Example 1. Factor to solve the quadratic equation. To solve the quadratic equation, we need to factor the trinomial. We're going to factor it into two binomials. So I want you to watch as we factor here. Get my blue pen. We're going to factor this. X squared is going to factor into x and x. Since 21 is negative, I know that I have a positive factor and a negative factor. The factors of 21 that will give me 4 when combined are 3 and 7. And since the 4 is negative, I know that the 7 should be negative. This is factoring. It was covered in a previous lesson. Now, today's lesson is about what do you do once you get it factored. Once you get it factored, each of these factors needs to be set equal to 0. If we multiply this term and we get 0 for an answer, that tells me that one of these or both of these must be 0. So what I'm trying to figure out is if this is equal to 0, what is x equal to? Or if this is equal to 0, what is x equal to? So I'll solve each equation. To solve the first one, I'm going to subtract 3 from each side. And I find that x is negative 3. To solve the second, I'm going to add 7 to each side. And I find that x is 7. These are the solutions. There are 2 of them. These tell us where the graph crosses the x-axis. Next example. Factor to solve the quadratic equation. Once again, we're going to take the trinomial and we're going to factor it. N squared will break down into n and n. The factors of 30 that will add together to give me 11 are 5 and 6. Both are positive in this problem. So I have n plus 5 equals 0, or n plus 6 equals 0. Solve each equation. To solve this equation, I'll subtract 5 from each side. So n can be negative 5. To solve this equation, I'll subtract 6 from each side. N can be negative 6. So the solutions to this problem are negative 5 and negative 6. Those are the two locations where the graph crosses the x-axis. Example 3. Solving using the quadratic formula. Not all trinomials can be factored. When they can't be factored, we use what we call the quadratic formula. It's listed here. It says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. The first thing we must do is we must label a, b, and c. To do that, you'll need to identify your a value. Your a value is always the coefficient of your x squared term. So this time a is 1. B is your coefficient of your term x to the first, or just plain the x. And c is always the constant. Now we'll plug these into this formula. So we have x is equal to negative b. there's a negative sign in the formula. There's also a negative sign on the b value. When I put those together, it's going to be positive 5 plus or minus the square root of b squared minus 4 AC all over 2a. I'm going to start simplifying under the radical sign, so I'm going to have x is equal to 5 plus or minus the square root of. When I square negative 5, that gives me 25. When I multiply 4 times 1 times 6, that gives me 24. When I multiply 2 times 1, I get 2. So I have x is equal to 5 plus or minus the square root of 1 over 2. I'm going to take the square root of 1. So I'll have x is equal to 5 plus or minus 1 over 2. Now it's time to split this apart. The plus and the minus means that you need to evaluate it if it's a plus and if it's a minus. So I'll have x is equal to 5 plus 1 over 2. X could also be equal to 5 minus 1 over 2. So x could be 6 over 2, which is 3, or 4 over 2, which is 2. The quadratic formula will work no matter what situation you're given. Next example, use the quadratic formula to solve. First step in using the quadratic formula is to identify A is 2, B is 4, C is negative 7. Now we're ready to plug these in our formula. X is equal to negative B, so I have negative 4, plus or minus the square root of B squared minus 4 times 2 times negative 7 all over 2 times A, which is 2. Now I'll begin to simplify under the radical. X is equal to negative 4 plus or minus the square root of 16. When you have a minus here and then you multiply, we're going to get negative 56. 4 times 2 is 8. 8 times negative 7 is negative 56. So this is going to be plus 56 all over 4. So x is equal to negative 4 plus or minus the square root of 72 over 4. I'll simplify the square root of 72. X is equal to negative 4 plus or minus the square root of 72 is like having the square root of 36 times the square root of 2. I know the answer to the square root of 36, it's 6. So this is 6 square roots of 2 over 4. So I can split it apart, and x could be equal to negative 4 plus 6 square roots of 2 over 4. Or x could be equal to negative 4 minus 6 square roots of 2 over 4. Each of these needs to be simplified. 4, 6, and 4 are all even, and 2 will go into each of those. So I'm going to divide through by 2. So this one is x is equal to negative 2 plus 3 square roots of 2 over 2. Do the same thing here. X is equal to negative 2 minus 3 square roots of 2 over 2.